Okay. Now what all of these sections have been building to is 6.6, where we're solving exponential and logarithmic equations. So there's a whole bunch of different things that could happen in here. But what we're really doing is we're going to use the rules from all of the sections leading to here to solve. So if we look at this first one, the bases are the same. Both sides have a base of 2. So if they have the same base and they're equal, the exponents have to be equal. So as soon as it's the same base, it makes our life pretty straightforward. So that's supposed to say same base. So we can actually ignore the base and just say x minus 1 equals 2x minus 4. And now we're going to solve. So I'm going to subtract x from both sides. So I have negative 1 equals x minus 4. And then I'm going to add 4 to both sides. So I get 3 equals x. And that's all. So let's look at this one. We have the same base, so we can ignore them and say 2x equals 3x plus 2. Now to solve this, I can subtract 3x from both sides. So I get negative x equals 2. And we need the x to be positive, so I'm going to divide by negative 1. So I get x equals negative 2. So when the base is the same, it's pretty straightforward. Now let's look and see what if the base is not the same. Well, we're going to try to make it the same. Can you make the base the same? Make base, same base. So the way we do that is we try to find different powers that equal the same thing. So, for example, 2 to the first is 2. 2 squared is 4. 2 cubed is 8. 2 to the fourth is 16. So here, 8 and 16 can both be written with a base of 2. So instead of 8, I'm going to write 2 to the third. Instead of 16, I'm going to write 2 to the fourth, because those equal the same things. Now our power to power rule means we multiply. So 3 times x is 3x, and 3 times 2 is 6. And then we do the same thing over here. 4 times x is 4x. 4 times 1 is 4. So we're distributing the exponent. And now we have the same base. So now we can ignore them and solve. So I'm going to subtract 3x. So I get 6 equals x plus 4. And I'm going to subtract 4. So I get 2 equals x. So let's look at another one that's kind of similar. So we have a 5 and 25. Now I may go, oh, hey, 25 is 5 squared. 5 times 5 is 25. So I'm going to leave this one, but I'm going to rewrite the 25 as 5 squared. So that's the goal. You're just going to take the numbers that are there and see if you can make them have the same base. Then we would distribute our exponent. So 2 times 3x is 6x, and 2 times 2 is 4. Now that the bases match, we can ignore them. So 2x equals 6x plus 4. I'm going to subtract 6x from both sides. So we get negative 4x equals 4. I'm going to divide by negative 4. So I get x equals negative 1. Okay, so that's what happens when they're not the same. Now we'll look, we got a radical here. So from what we talked about in the last unit, you can rewrite a radical with a fraction exponent. So you take the exponent that's there, and that becomes the numerator, and the index is a denominator. Whatever the big number is your base. When there's no exponent, it's a 1. That's where the 1 came from. And if I just give you this symbol, we've always known it as a square root. That's why it's a 2. So if there's no numbers, that's what we have. Now, just like before, the bases are the same. So 5x equals 1/2. I'm going to divide by 5. And 1/2 divided by 5 is 1/10. Okay, so let's do the same thing over here. We're going to take the 5 to the x, and then we're going to rewrite this as 5 to the half. Now we ignore the bases, so x equals 1/2. All right, so those are some exponential ones. Now look at some log ones. So here we have 2 ln x plus 3 equals 7. We can't do anything. Our goal is to get the ln alone to start. So I'm going to subtract the 3. So 2 times ln x equals 4. I'm going to divide by 2. So now I'm left with ln x equals 2. We're going to use that exponential rule to rewrite it. So remember, ln is the same as log base e. So if I rewrite that, it's e squared equals x. And that's what we want. We want to know what x equals. Now, when you have an e in there, you're just going to leave it. That's called in terms of e. So leave in terms of e. There's no point in figuring it out and rounding. E squared is fine. So once you have x equals, that's where you're going to stop. So if we do this one, we want to get the ln x alone. So we're going to subtract 6 from both sides. So, I don't have them there. So ln x equals 4. Then we're going to rewrite that as e to the 4th equals x. And that's enough. All right, let's try 2 more. So just like before, we need to get the ln alone. So we have ln of 6x equals 7 divided by 2, which is 3.5. If I rewrite this, it's e to the 3.5 equals 6x. But we still need the x alone. So we're going to divide both sides by 6. So e to the 3.5 over 6 equals x. And that's fine. Leave it in terms of e. There's no point in rounding when we can get that close. All right, so we go over here. We're going to divide by 2. So we have ln of x plus 1 equals 5, because 10 divided by 2 is 5. Rewrite e to the 5th equals x plus 1. And then to get the x alone, we subtract. So e to the 5th minus 1 equals x. And that's all we have to do. So it's not super complicated. It's just a matter of remembering all of the rules. So that is section 6.6. Let me know if you have any questions.